about this.
Square root of a
6a and I meant 8.
I meant 22 degrees. I told you.
See now.
Okay, good afternoon. Please put your pencils down and pick up your colored pens. Let's see how we did with foiling. So stay on your toes. You call on your number. And tell me what you got for the question. So number 1, what did you get? I got student 4 and 19. What'd you get? Student number 19. So 2 students agree. A squared minus 9. Number 2, going down. I got student 12 and student 17. Student number 12.
A squared minus 16.
So you 2 agree that it is a squared minus 16. Number 3, I got student 10 and student 9. Student number 10.
A squared minus 25.
Student number 9. So you 2 agree that it is a squared minus 25. And number 4, I got student 20 and student 16. What do you say?
A squared minus 36.
So you 2 agree that it is a squared minus 36. Numbers 5, 6, 7, and 8. Stay on your toes. I got student number 2 and student number 13 for number 5. What'd you get?
X squared plus 4x plus 4.
Okay.
X squared plus 4x plus 4.
X squared plus 4x plus 4. Number 6, I got student 24 and student 15. Okay, I got student number 15 and student number 1.
X squared plus 6x squared plus 9.
X squared plus 9.
X squared plus 6x plus 9. Number 7, I've got student number 5 and student number 14.
X squared plus 8x plus 16.
X squared plus 8x plus 16.
X squared plus 8x plus 16. And for number 8, I got student 18 and student number 9. It wasn't an optional question. Anyone notice anything? Anyone notice anything? Start with Tristan and Cheyenne and then Yasmin.
Well, like inner, the inner and outer. So like if you multiply 3 times a, you get positive 3a. I'm talking about number 1. And then if you get if you multiply a times negative 3, you get negative 3, and then those will cancel each other out. So and it's for the same for 1, 2, 3.
I love the way you started that out. What was the first thing you said?
Said it started like with the inner and outer.
Yeah, the outer and the inner. And then you basically ended up saying that the outer and the inner cancel each other out. Isn't that interesting? And then you said something about all of them.
Like they all have like it's the same, the negative and the positive.
Oh, okay. Very good. Who was next? I lost my order. Go ahead, Cheyenne.
I see like they're starting in kind of like numerical order from like the first 4 are starting in numerical order from -3 to -4 and adding 6.
Mm-hmm.
And the second set 5 through 8 is like 2, 3, 4, and 5.
Okay, good. Yasmin, what did you notice?
I was gonna say what Tracy said.
About the outer and the inner? Okay. Gary? They both have their own pattern. Okay? So then let me ask you this. Let's forget about 5 through 8 for a moment. Let's just look at this. If I now asked you to do a plus 8 times a minus 8, do you think you could do it mentally without doing anything?
Yeah.
If I said do a plus 10 times a minus 10, would you be able to do that mentally now that you see them all together? How about we go ahead and do that?
What?
So, I'm doing something different. I've got a little warm-up follow-up. So, I want you to do these 3 questions. They're not numbered. I want you to do this, this, and this, but you've got 1 minute to do it. And I'm willing to bet that you can do it in under a minute. Go. You should be done with the first one already. You should be done with the second one already. All right, give me this one. Good, Kaylee.
8 minus 49. A squared.
A squared minus 49. What about this one right here? Okay, Chopin? I would have expected you to get those in 10 seconds or less. Here was the harder one. Let's see who was able to do that. Laurel, and then we'll go to Paige. What do you think?
4a squared.
So we have 2 proposals. We've got 2a squared minus 9, and we have 4a squared minus 9. Anyone have another proposal? Gary, what's your proposal?
2a to the 4th minus 9.
Minus 9. We have 3 proposals. Any other proposals? Well, I will say that one of them is correct. But now what I would like to do to figure out which one's correct is now start here and go down and then go down and now tell me which one makes the sense, which one follows the pattern. Which one follows the pattern? Give me a thumbs up when you feel like you know. Which one follows the pattern? Which one, Tyler?
4a squared minus
4a squared minus 9. It's harder to see because the pattern looks like that it's just a squared every time. Like you didn't have to think about it. But that's not really what was happening, was it? What we were doing was squaring the first term. Square that. Square that. Square that. Square that. Yes, it happened to come out the same every time. Square that. Square that. Square that. 2 squared is 4. A squared is a squared. So you're not just writing a squared. That's not the pattern. You're actually doing something. You're squaring the first term. You're squaring the second term. And then you put a subtraction sign between them.
You remember how when it has an exponent like on the outside of the parentheses?
Mm-hmm.
Like we could have just done it.
Well, we'll get to that in a minute. So what about this? You see the pattern? See the pattern here? So let's go back to what Tristan said. We want to now know what this pattern is from 5 through 8. But I want to go back to what Tristan said about these. What did you say happened to the O and the L for these, Tristan? Okay. And so it was because you had a great explanation. It's because one of these was positive and one was negative. And what happens is when you multiply it out, you end up with opposites that cancel each other out. So now, let's think about this. Something is different. What's happening now?
Oh.
Canalita, and then we'll go to Yadesh. Okay, so they're not getting canceled out. Okay? Yadesh, what were you going to say?
Positive, and then they don't cancel out.
They don't cancel out. Good. But do you see a pattern? So you're right. They don't cancel out. So we end up with a middle term. Listen carefully to this. These, there's no middle term. There's a first term and a last term, but there's no middle term. No middle term. Now all of a sudden, we have a middle term every time. But look at the first term and the last term. Look at here and look at here. Now, where does the middle term come from? That's the question. Where does the middle term come from? So they don't cancel out, but what is happening? Now look at your paper. Look down all 4 of these questions and look at the work that you did. And give me a thumbs up when you see it. Look down your work that you did for all 4 of these. Give me a thumbs up when you see it. Paige, what do you see? Sure.
So we multiply the x times 3, and then I did the distributive problem.
Yep.
When you multiply the x times 3 and the 3 times x, then you get 3x plus 3x.
So how many 3x's do you end up with? And what about in number 7? What do you end up with? And so how many 4x's are there? And for this one, how many 5x's are there? And how many 2x's are there? So now if we did these, how many 6x's would there be? So what will the middle term be? If I want the middle term for this, someone tell me what the middle term is going to be. Chanel? It's going to be 12x. Could you also tell me what the first term is going to be? And what about the last term? Could you tell me what that's going to be? And since this is plus, that's going to be plus, and that's always going to be plus. And wow, you just did today's lesson. So we have a lot more to go, and we're going to be exploring this in quite a bit of depth because it can get a little confusing, but this is basically today's lesson. So let's go back. The point was that these are special cases. That's why I say it's called special products of polynomials. These are special cases, but they follow a pattern, and they are incredibly important. And I cannot overstate this. I cannot overstate it. These are going to be critical in the near future. Because what's coming next in Chapter 7 is learning how to go backwards. And going backwards is harder than going forwards. And if you are aware of special cases that are really easy to figure out, going backwards is much easier. Now, you'll be able to figure out everything without doing any special products, anything. You won't have to know any shortcuts. You don't have to. But if you're sitting next to someone who knows all shortcuts, and you don't, and you're in a job interview, who are they going to pick? The person who knows all the shortcuts and gets it right every time. So do I want you in my room being the average person who's going to the job interview and knows your stuff, but just knows it and can do it the long way? Or do I want you to be the person sitting in the room who knows it better than anybody else, who knows it faster than anybody else, and can do it like it's no big deal? Hopefully you know the answer is clear. So, let's move forward. Any comments or questions? Any other observations? All right? Okay. So, we've done well so far. You guys did a great job during today's warm-up. And we got a lot out of it. Not only was it a refresher of last time, but it led directly into today's lesson. And so we already know a lot of what's going to happen. But now I'm going to formalize it. And I am going to put some words to it, and you have to know the words. So, we're going to start with the first pattern that we saw during the warm-up. It has a name. It's called the sum and difference pattern, and you have to know its name. Anytime I show you two binomials multiplied and they're both the same except one of them's plus and one of them's minus, you immediately should be able to tell me that it's a sum and difference pattern. That doesn't mean right at this moment you can, but by next week, it should not be an issue. And just to be clear, a plus b times a minus b is the same thing as a minus b times a plus b. Just like 5 times 2 is the same thing as 2 times 5. They're both factors. That's a factor, that's a factor. You can rearrange them. That's a factor, that's a factor. You can rearrange them. So here's what we discovered. It goes back to what Tristan articulated so beautifully, is that when you FOIL this situation, the O and the I cancel each other out every time. So let's make sure we see that. And that's why I asked you to leave a few lines of space. So here's my example. Following the pattern, we already know it's going to end up into that. The first term squared, the second term squared, and then we put a subtraction sign between them. But let's see what happens when we do the FOIL method. FOIL, first terms, 3x times 3x, 9x squared. Outer, 3x times negative 4 is negative 12x. Inner, 4 times 3x is positive 12x. And 4 times negative 4 is negative 16. No matter what the numbers or letters are, this will always happen. The middle terms will always be opposites. And because they are opposites, they will cancel out. Any questions about that? Could someone explain, now that you see it, could someone explain why it's always a subtraction sign? Why is it always going to be a subtraction sign? Alex?
Because the inner and outer numbers are opposites, so we multiply opposites.
Very good. So in this case, which numbers were you talking about?
The positive 4 and the negative 4.
So let's go back to the warm-up and look and see if he's right. Right? When you multiply those, they will always come out negative. And so he is absolutely right. And that's why when you do a sum and difference pattern, it always is square of the first term minus the square of the second term. Anyone have any questions about that? Now, I want to point out something really important, is that when you do FOIL, this is supposed to add into a middle term. It's supposed to be a middle term. There's supposed to be the first term, it's supposed to be the last term, and then there's supposed to be a middle term. I'm going to say that phrase, Kaylee, over and over and over again. Middle term. Middle term. Okay? But what we see is the middle term disappears. So no middle term when there's a sum and difference pattern. But now we have the second pattern that we discovered during the warm-up. It's called the square of a binomial. So what we're talking about is a binomial times itself. That's what this means. Binomial times itself. Maybe you're wondering, well, we didn't see that during the warm-up. I'll put this back in a second. Well, let's go back to the warm-up. I don't see any squares anywhere. But what could I do with this right here? How could I rewrite that whole thing? Now we see it. How could we rewrite it, Kaylee? Very good. We could rewrite this, and I accidentally erased too much, but we could rewrite this as x plus 2 squared. And this one could be what, Tristan?
Or can be x plus 2 parentheses.
This one.
Oh, x plus 3 squared.
Good, and what about this one? This could also be rewritten as what, Amari? So these could all be written as square of a binomial, and that's why this applies. So the difference is, and we discovered this, is that now there is a middle term. Oops, excuse me. Now there is a middle term. Here it is. So a square of a binomial has a middle term. We already talked about why, and you analyzed it using your warm-up, but let's show it one more time. This really means x plus 4 times x plus 4. FOIL it. Remember I said we were going to start saying FOIL it a lot? FOIL it. First terms, x squared. Outer is 4x. Inner, 4x. Oh, look at that. And last terms, 16. And so Paige did a lot of the effort for us during the warm-up when we were kind of trying to go deeper. But how many 4x's showed up? How many 4x's showed up when I FOILed it? Cheyenne? 2 of them. And so what we do is we double the 4x. So you can think of it 2 different ways. You could say 4x plus 4x is 8x. That's where this comes from. Or you could say double it. In other words, 4x times 2. Now look at what I have written right there. Now you know where the 2 comes from. That 2 comes from 2. That 2 comes from the 2. So to get the middle term, you multiply these 2 times each other and then double it. And I'm telling you right now, none of this is hard except that students forget to double it. Am I an expert at Algebra 1? Yes, I've been doing this for a very long time. Am I telling you what I know to be fact from past experiences? Absolutely. Why am I telling you? So that you don't make that mistake. Students forget to double it. Now, if I give you a page of 100 questions and you do 98 of them correctly and you forget to double 2 of them, I don't really care. That's like a small moment where you messed up. But if I give you a page of 10 questions and out of 10 of them you forget to double 6 of them, that's a huge problem because you're not getting it. You have to double it, and this is why. Any questions about that? Kelly?
In the example when it says the 2 times AB,
This is just explaining this right here. A is this, B is this. Okay? What's 4 times x? Now double it.
You said it.
This is A, that's B. Multiply them together, what do you get? Now double it. Okay? So that's where the middle term comes from. So I keep saying this phrase, middle term, middle term, middle term. Sum and difference pattern, there is no middle term. Square of a binomial has a middle term, and it's double. Any questions? Good. Now let's actually start working.
Wait, what was that big space?
So, example 1, part A, square of a binomial. The whole point of all this is efficiency. The whole point of all this is for you to be faster, smarter, more efficient than the person next to you. So, square of a binomial. Let's see who's catching on. Part A, is there going to be a middle term or no middle term? Raise your hand and offer up an opinion. If you get it wrong, maybe you'll be embarrassed for a moment, but it's not a big deal. Middle term or no middle term? Caleb?
Middle term?
There's going to be a middle term, absolutely, because it's a square of a binomial. So, figure it out. Square the first term means square the number, square the letter. Square the number, square the letter. 49y squared. We know that there's going to be a middle term, but let's hold off on that for a moment, and let's do the last term. Square the second. 9. This is always going to be plus. Now the middle term. Multiply these two together, and then double it. 7y times negative 3 is negative 21y. Now double it. What do we get? Jesse? Well, I don't know how it became positive. It was negative 21y. We multiplied by 2. So it's still negative 42y.
He didn't say square, he said double.
So now we end up with 49y squared minus 42y plus 9. Anyone have any concerns about that? So did we end up with a middle term? Absolutely. Any questions? Good. Let's go to part B. Up a level of complexity, but it's no different. Is this a square of a binomial? Is it the same binomial times itself? Yes, it is. Because look carefully. It's the same thing times itself. That's called a square of a binomial. Is there going to be a middle term or no middle term? There's going to be a middle term. Square the first term. Square the number, square the letter. 64k squared. Skip over the middle term for a minute and let's get the last. Square that. J squared. That's always going to be plus. Now, multiply these two together and then double it. So that's super easy. 8jk, double it. So what do we get? What's the middle term? 16, and it's not, doesn't really matter. You can do kj or jk. jk is alphabetical order. kj follows the pattern of the letters in the original. Doesn't really matter either way. Anyone have any questions? Any concerns? Any observations? Any theories? Okay, let's see how you do on your own. 2 questions, you got 2 minutes, and that's it.
Oh,
Wow, I need numbers.
So then you can always square it. Just square it. Okay, so had your time. The whole point is for it to be a shortcut. So let's see how we did. Keep in mind, I know what I'm doing and I already know what's going to happen. So let's see what if it actually happens or if my predictions prove to be false. So, part A, tell me what you got. I got student number 9 and student number 5. What'd you get? Part A only. Okay, student number 5.
B squared minus 1b plus 0 plus 5.
Okay, so we have a disagreement. Student number 1, what do you say?
Did I skip that because I have something very wrong?
How do you know it's wrong if I haven't revealed the correct answer?
Because I wrote it down wrong.
Okay, so you'll start us off on the second one. It's b squared minus b plus 1/4. I guess you could put 0.25, but that would be kind of ridiculous since 1/2 times 1/2 is 1/4. It's not really a big deal. So, part B, we'll start with Kayla, and then we'll go to, so we got student number 1 and then student number 13. Student number 1, what'd you put?
64x squared plus 176 plus 121.
Okay, student number 13, which I'm going to ask Tristan to do.
64x squared plus 176 plus 121.
So both of you accidentally did not say x, and so hopefully it's actually written on your paper and you just forgot to say it. But if it's a quiz or a test and you forget to write the x, then you're going to have a problem. So let's talk about part A briefly, and then we're going to move on. We got a lot of other things to do. So the issue is that you don't know how to deal with fractions, and I understand. But let's be clear. Squaring 1/2 is not hard. Someone say, tell us how. How do you square a half? So I can see that you don't know what to do. Okay, Amir, how do you square? Multiply it by itself. Could someone do it in an even faster way? Go ahead, Gary. Okay. So when you square a fraction, you square the top and you square the bottom. 1 times 1 is 1, 2 times 2 is 4. 1/2 squared is 1/4. What if I asked you to do 1/3 squared? Can you do that now quickly? Give me a thumbs up when you know 1/3 squared. Good, Yasmin, what is it? 1/9. So squaring a fraction is not hard. Then what happened is you didn't know how to add -1/2 and -1/2. Could someone tell us what's 1/2 plus 1/2? I mean, this is in Mickey Mouse Clubhouse, in an episode where they're trying to take care of a baby, and the milk spills, and they have to pour 2 half bottles into a whole bottle, and it's Mickey Mouse Clubhouse designed for 5-year-olds. Know that when you take a half and another half, you put it together, you get a whole.
That's the show right there.
So, when a 5-year-old can do a half plus a half is a whole, then my advanced students now know negatives. When you're 5 years old, you don't know negatives. You can't. Your brain will not allow you to do that. So now you know that -1/2 Going backwards a half and then going backwards another half means you've gone backwards 1 whole. So of course, -1/2 plus -1/2 is -1 whole. Okay? Any questions about that? I'm glad to see we have other fans of Mickey Mouse Clubhouse. Let's move on.
That's my brother's favorite show.
So, all right, so now I've grouped together sum and difference pattern. And then soon we're going to have to be able to tell the difference between the two of them. Sum and difference pattern. Now we have the same binomial almost. Almost the same, but we've got ones plus and ones minus. Notice in part B that the first one is minus and the first one is plus. We already discussed briefly the fact that that doesn't matter. So now, answer my first question. Middle term or no middle term? Someone tell us. Middle term or no middle term? Ooh, lots of confidence now. Good, I like to see that. Adriana, middle term or no middle term? No middle term because of what Tristan explained. Because we have opposites, they end up canceling out. So this is even easier than the square of a binomial. Square the first term. Someone tell me, what is it going to be? Square the first term. Keshobe? 81w squared. Square the second term. Someone tell me what that's going to be. Oh, that's ridiculous. That's 9. And someone tell us what operation goes in between. We discussed already. Jesse? It's always going to be minus, and so we just did a sum and difference pattern. Anyone have any questions or concerns? Questions or concerns? Any observations? Okay, let's go to part B. Part B. I'll get back to that in a moment. So, square the first term. Ooh. What's it going to be? Yasmin?
Squared. N squared.
Good. 1/9 n squared. And square the second term. What's that going to be? Alex? 36s squared. What is going to go in between them? Kaylee? Subtraction, always. Anyone have any questions? Catalina? And so I'm glad you brought it up. If you are having trouble, you can FOIL it. Absolutely. But I want you to understand, and I'm going to give you a big warning, that when we go to the next chapter and we have to start going backwards, there's going to be people in the room that are going to be flying past you. Because going backwards is much harder. And if you know these shortcuts, then you will be able to go so much faster. Right now, this is just a little bit faster. I'm telling you, going backwards is much harder, and knowing the shortcuts allows you to go much faster. But no matter what, you can always FOIL it. And Catalina, you're not the first person to bring it up today. There's been 2 students who already brought it up before you. They said, can I just FOIL it? And I said, absolutely. But eventually, you should be able to do it with the shortcut. Anyone have any other questions? Okay? So, checkpoint number 2. This time you got 1 minute. You should already be done with part A.
Yes. Shut up, you dad. Shut all the way up. You don't even know. This 144 stays in there. No, you don't even know it's
Minus
I said it. I just changed it before you even said minus here. Because I have to make it. Number B? You know what I meant. There's no number B and there's no capital A. I got it. There it is.
Oh, yeah.
You would. Thank you.
All right, let's see how we do. All right, part A. I've got student number 9 and student number 4. Student number 4.
16b squared minus 36.
Part B, I've got student 18 and student 3. Student number 18. Student number 3. Say it again.
144 squared minus f squared.
Okay, so it is 144 minus f squared. So, you know what you're doing? You just, the pressure kind of made you make a simple little error. So, now we're back as a whole group. Any concerns? So you put negative f squared plus 144? Fine. Any other comments, questions? Okay, so now I'm going to do something different. I'm going to put up another checkpoint. Totally different. Totally unrelated. Your job, and trust me when I say that I know what I'm doing, your job is to figure out the answer to the question. Figure out the answer to the question. You're trying individually, and then eventually you may discuss with your team. I'm going to give you about 4 minutes to figure it out. I'll be honest that it is an incredibly easy question. But you're going to need to take a moment to kind of pull things from the past back. Because it's from way long ago. Way before, probably before middle school.
Oh my gosh.
So, you got 4 minutes.
4 minutes.
4 minutes, find the answer to the question. I'm willing to bet that you can figure it out in 1 minute or less.
Alright.
So, now's the point where the giggling and the Lucy-ness is gone, and now we're back to work.
Valentine's, bro.
Oh, around the world.
Done.
Done. I don't get it.
Chicken.
So, got a lot of people confidently shouting done, so we'll go ahead and drop it to a minute. If you feel like you are done, quietly compare your answer to your teammates to see if you actually got the same answer. Then you got to figure out if you're actually correct.
She got the same thing.
Hey, where's my pen?
I got a van for free. I told you because my neighbor's a teacher that works there. I want to go away anyways. I gave it to my sister. No, too expensive. $50 just for a student van. 60.
Okay, so there was a lot of kind of wasted time there, it seems. So hopefully that meant that this was easy and that it was no big deal for you. So let's get some answers first and then we'll talk about how. So what is the answer to this? And since it seemed like everybody was involved, I should be able to call on anybody in the room and it shouldn't make a difference. So let's see what the answer is. So I got student 21, 18, and 15. Student 21. Oh, hold on. One more time, please. Okay? So you all agree that the answer is 172. And since we don't know what unit of measurement is being used, it's in square units. But let's talk about how. This is the important part. How? Someone give me one number that we needed. Give me a number that we needed. Amari, give me a number that we needed. Okay, so we needed to do 14 times 14, and that told us what, Amari? Right, but that tells us what in words? Okay, could someone, she's right, but now I need it in words. Laura? Okay, so well, it's not the area of the yard, but I understand what you mean. It's the area of the whole space, right? It's the whole thing. So it does come out to 196. Now someone give me another number that we needed or something else that we had to do. Giant? So we had to do 6 times 4, and what did that tell us?
24, that's the area of the pool.
Okay, so that's the area of the pool. But the answer is not 196, and the answer is not 24. How did we get from these two numbers to the answer? What did we need to do now? Adriana?
Subtract.
We had to subtract them. Why?
Because you're not including the pool.
Okay, I love the way you said that. We're not including the pool, and when you don't include something, you subtract it from it. Okay? So let's review. First, we had to find the area of the whole space. That was using these. Then we had to find the area of the space we're not including, and then we subtracted them. Give me a thumbs up if that makes sense to you. Okay? Any concerns? Okay. What level of schooling do you think this is an appropriate question for?
First grade.
What level do you think? What level of schooling do you think, Garion? Okay, that's. If I had to guess, I would have said 4th or 5th grade by today's standards. Could be even earlier, but I'm not sure. But so you are not clearly in 4th or 5th grade. In fact, you are, for all intents and purposes, in 9th grade. So you're way beyond this. So what is my purpose? Is a very important purpose. I am now going to put up another checkpoint, and it's a team challenge, which means that right from the get-go, you have your choice. You can work individually or with your team. And instead of being, whispery and quiet about it, you can really engage in discussion about what's supposed to happen. And see if you can follow the logic and figure out why I did this question and then the next one. All right? So I'm going to turn the page, and then you're off and running. Ready? Go.
X squared.
Five. No, it's not.
Oh, I got one.
Remember, I can explain it, but I have to explain it.
Not the area, but the area just the area not the area.
Oh, now we have the areas.
Of the yard. It's not. You have to subtract.
Let's make it with this parentheses minus.
What?
This is what we just did. So then do minus.
Which is better. X squared minus x squared minus
Because it needs to be a middle.
You multiply
It has to
x
have a
squared, then you subtract it. You give that, which is x squared minus x. What'd you get?
I got the one around. I think I'll send it plus 25.
How'd you get x squared minus x?
X squared plus 10x.
You don't tell about what you want, y'all.
You're saying the end, you're saying
Oh, I know what it's How do you get that? Oh, wait, it's x squared plus
I was right when you said no.
because I was thinking about the other one.
See, I told you I had it right.
Oh, that's x squared minus x squared.
No, it says right up polynomial. It's solved.
I know, I just wanted to stop wrong.
Let me see.
this thing.
That was so funny.
Shoot.
Mr. Gallen.
That's not one second. What did you see?
And then first,
I'm gonna leave this here. I put in parentheses x squared plus 10x plus 25.
X squared minus
X squared
4. What was the other one?
Because you have to subtract the two. To get there, you have to make, so you have to multiply those two by two, multiply those, and then take the two equations and subtract them. I don't see where you can multiply. And then turn it into x plus 2. And then x plus 5.
Okay, so
Say again? I don't see where you can't just take x plus 5. And then subtract that from x plus 2 squared, which is equal to minus 2. Oh, I agree.
Jasmine, what's good? Any equations? I got 20. Good. 10 plus 29.
How did you get 0 to 9? You're not supposed to solve it.
I know.
So why did you solve it?
Because I wanted to.
Okay, so, right or wrong, let's get some answers, and then we'll talk about the how, what, and why. So we got lots of confident people, but I want to hear from everybody. So, let's see what we got. I got students. I can't get it to stop. Okay, I got student number 14, 4, 1, and 17, and 7. Student number 14. What'd you get?
10x plus 21.
Okay. Student number 4.
I got 2 answers.
Well, give me one of them.
One of those was, I don't know which one to give, so I got 10x plus 29.
Okay. Student number 1.
Kayla.
Kayla. X squared plus 4 minus x squared plus 25.
Okay, student number 17. Okay, student number 7. The correct answer is
No, Mr. Gallup.
We got it wrong.
Oh my God.
So, I will say this. Hear me. So, I will say this, that if you got 10x plus 21, then you did everything right except you missed one little detail that was really important. Unfortunately, it does mean you got fired from your job, but the good news is that hopefully your next job you'll do better. So, let's start out with this. I need a starting point. Can someone give me the starting point right here? Tyler.
Open parentheses, x plus 5, close parentheses, open parentheses, x plus 5.
Good. And now when you do that, you get what?
You get x squared plus 10x plus 25.
Okay, now be honest, Tyler. I want an honest answer. Did you FOIL it or did you use the shortcut?
I used the shortcut.
Good for you. So now, if you didn't, doesn't matter. So now, what was the next thing we needed? What was the next thing we needed? Next expression. Garion?
X plus c times x minus 4.
Good. And what's the result of that?
That is x squared minus 4.
X squared minus 4. Very good. Now what do we do with them? And for those of you who didn't know, now you'll know why I did this. What do we now do with them? Paige?
Okay, you gotta put the x squared minus 4 in parentheses and then put a subtraction sign before it.
And Paige, why is those parentheses important?
Because that signals that you have to distribute the negative.
I love the way you said that. It signals that you must do this. Oh, there's the 29. Oops. So when you subtract an expression, you're subtracting the whole expression, which means that you have to put it in parentheses. If you leave the parentheses off and you wrote this, then yes, I would understand that x squared minus x squared cancels each other out, but you did not address the fact that we're subtracting a negative 4. Subtracting a negative 4, you have to deal with like this. So I love the explanation. So, I'm impressed. This is the first group where I had anyone who got it right. So you guys should be proud of yourselves. And for those of you, again, who got 10x plus 21, you did all the algebra. You did all the hard stuff. You made a small mistake, and that's okay. Now, moving forward, you watch out for that mistake. Are there any comments or questions? Cheyenne?
Well, I don't think I was supposed to do this, but the x squared minus 4, I pretended that there was a middle number, and the middle number was 0.
Okay, and that is
made it
appropriate.
easier for me to figure out the 10x plus 29.
Good. Good, I'm impressed, because when you subtract the two, you were able to line it up better. I think I saw in your paper that you put like a 0x underneath so you could line it up. Good, good for you. And so she's doing something more than just a simple, made up something. She did something really important. And this is what I keep encouraging you to do, is you have to, in this class, look deeper than what I do with you. You have to look beyond what I do with you. Yes, I'm the guide and I'm teaching you, and I understand that. But if you just go by exactly what I say, and that nothing beyond what I say is possible, then you're being foolish. Because there's a zillion things beyond what I say that are possible. It's your job to find all those things. Shortcuts, patterns, things that make your life easier. I don't know all of them. You're the creative ones. You're the bright ones. You are able to come up with ways that are creative and different. That's part of your job. It's part of my expectations for you. Okay? Anyone have any other comments, observations? Catalina?
Why does the theoretical and nominal
Okay, so this goes back to the day I introduced these words, and I think it was Paige who said, I don't understand, if it's going to be a polynomial, doesn't it have to have more than 3 terms? And then I talked about money. Didn't I talk about money at that point?
Yeah.
Then I pull out a dollar bill, and I said, what do we call this? And we said that it's a dollar bill, but it's also called money. And I believe I then said, which one's more specific? Right? Dollar describes this specific form of money, but I could call it money, right?
Yeah.
I could say, hey, I've got some money. Or I could say, hey, I've got a dollar. One would be more specific. So the question is, the point is if I said write a binomial, that would have given part of the answer away. Polynomial is a term that describes everything. It describes monomial, binomial, trinomial, and everything beyond it. So it was intentional. Does that make sense? Okay. That's a good question that you brought up. Okay. Any other questions? All right. Your homework is page 361. You're doing numbers 1 through 20, but I can't remember exactly how it was, but one of the questions had 2 parts or maybe 3 parts or something like that. It works out to 23 separate questions. Grade them separately. And your test on chapter 6 will be next week. Let me see. I see you on Tuesday. We don't see each other on Tuesdays, so then Wednesday, Thursday. So it'll be next Thursday.